hermetically sealed. If you notice, there is probably a hole on almost every one of your drives that says, do not cover this hole. There is air traffic going through the drive, and it's helping it create a nominal amount of pressure so that the pressure can equalize between the outside and the inside. Otherwise, you'd start having problems with your drive at different altitudes and things like that. And there are times where if you're up high enough in a plane that your hard drive could actually crash because there's not enough air pressure to keep the head floating over the platter, and it will hit the platter and start to scrape it. But there are some hermetically sealed ones, like Air Force and things like that have some hermetically sealed drives, but you're not going to find those on the shelf at CompUSA or wherever you're going to go and buy one of these drives. So you can kind of take the cover off of your hard drive and look at it. Unfortunately, after you do that, it's going to degrade, and you're going to have a shorter period of time. But if you've got a drive that's damaged already, this is another one of those kind of things where a lot of the data houses are kind of trying to scare you into going with them or trying to make you send these things in so you can spend your thousands of dollars as, you know, got to have a clean room, you got to do all these other things. And a clean environment can be produced in a number of different ways. There's clean boxes, you can make them out of Tupperware, there's a number of ways to do this. But one of the other things that happens with a hard drive, when the platter starts to spin, the manufacturer already knew at the time that they were manufacturing the hard drive that there were going to be little fragments that were going to come on and off of the platters. And when they start to spin up, it creates an air bearing, and it flings those pieces off of the platters into, and in some cases you'll see when you open up your casing, there's like little tunnels around the edges of the metal of the casing. And they're basically there to capture little fragments as they fly off. They even have a little filter, and it looks like a little tiny pillow. I'm sure, has anybody here opened a hard drive before? And you've seen that little pillow, the little tiny pillow, and some of them are removable. You can just take tweezers and pull them out. And some of them have like a little cap on the top of the metal when you take it off and things like that. But there's really good ways to get an indication of whether or not you've got platter damage further down on a drive by looking at those pillows. Because if they're silver, you might not be able to see the scratch on the top, but there may be a really deep scratch on the bottom because the magnetic media has gotten scraped off. It flings out into those tunnels and gets caught into one of these pillows. And so a lot of times you can know right up front whether you've got some really physical damage by looking at those. So we're going to break the pieces down into the two segments that we basically look at are the platters themselves and the way that the data is written to it. The important piece here is this alignment servo info. Before 1986, every hard drive had a stepping motor. They basically would move this motor an increment at a time with a, pulleys, wheels, slash whatever. There's different ways that they did it. But it would always move in the same increments. But the problem is that motors are not exact enough that over time they don't degrade their performance as well. They wouldn't move to the same location. So they didn't have the servo info in those original drives. They actually had to keep reading the data and trying to do something with the data. When they came out with a voice coil, which was Connor's gift to us as far as hard drives, because every hard drive you have today has a voice coil in it. When they came out with the voice coil, the motor didn't know where it was when it would move the head of the hard drive over the platter. So the servo info is geographical information that is constantly being read at all times while the head is spinning over the platter. And it will read it and tell the system where I am on the platters at all time. The big thing here is that you can't get to that servo info. You can't read that servo info. This is one of those changes where all of a sudden we have IDE hard drives and we can't low-level format an IDE hard drive, or it really screws the system up if you can even get to the low level. But we all used to low-level our drives before we got to this point. So the servo info is written by a piece of hardware at the manufacturer's plant. So when they change a platter, they change its location or whatever, that servo information gets written back to the first board, the IDE board on the bottom of the drive itself. And that information gets saved there to tell it where you're going and what's going to happen and where this platter is. So that's why when you change the board, if you don't get the exact board that was made at the same time, and it's a little bit of guesswork on getting that board, if you don't get that board, it's not going to know what the servo information was, and it's not going to be able to put that head back in the right place. So that's the most important aspect of doing any of this data recovery stuff. And if you have multiple platters, I kind of mentioned before that if you had multiple platters on a motor, you just couldn't pick them up and move them. Because that's the other question I get all the time is like, okay, well, if the drive is bad, let's just take our platters off and let's go get another drive and put them in that and it'll work. Well, if you have two platters and they free spin when you take those screws off the top, and you'd be surprised at how little there is any pressure or anything in there that holds those platters in place. But the problem is the cylinder, because the data that's written, and especially the servo information that's going to matches from the top of the board to the bottom to the, each platter is exactly aligned above each other. And if it was moved even like a 0.05 microns, it would never line up again, and you would never read the data off of that drive, because the piece of data is written on top, and then it's written on the bottom, and then it's written on the top of the next platter, and that's what makes up the cylinder that you always hear, cylinder head, blah, blah, blah. And so that's where that information, if the two platters is turned, that's it. It's all over. You will never be able to read it again, at least not without some really, really extreme measures. So the voice coil is down here on the end of the arm of the hard drive's head. And the voice coil works exactly the way that the speaker does. Basically, it's putting an electrical pulse through the tail, and it causes the arm to move back and forth over the location of the platters. So that's one of the reasons why, because it moves so fast and it moves to a certain location, that we can't tell, like we did with the stepping motor, where things are, and that's why the servo information is there at all. So this is the way that this works, and basically the magnets are pulling it in one direction or another, causing that head to move in extreme fashion back and forth. And this head can move back and forth over the platters 60 times per second. That's much faster than the stepping motors that we had up until about 1989. And Seagate and several other manufacturers were still doing that up until 1989 before they switched over to the voice coil that we use now. The air pressure, basically the way that this works is the head of the hard drive used to actually sit on the platter. In the 1950s, in the early 1950s, when they first made the hard drives, the IBM made them so that they had tracks on each side of the heads, and it sat on the platter and scraped along the platter on the orange stuff, which used to be the iron oxide. It's basically rust on the platter. So you can imagine that as the head was moving over the platter, if there's rails and they're touching the platter, eventually it's going to cause a lot of wear and tear, and these drives are going to go bad. And these things you would have 24-inch platters, and there could be 50 of them in one hard drive. And so when one went bad, it was extremely costly and extremely difficult to get in and replace one and get one running. So basically, through an anomaly, one of the guys figured out that when the platters are spinning fast enough, if you took some of that weight off of the head, it would actually float over the platter. And so by 1963, they switched over to having a head that floats over the platter, and it's never gone back since then, because it basically eliminates that whole wear and tear that would actually happen on the drive. So when you hear that a head hit the platter and you have a crash, sometimes it doesn't actually cause a crash, but it can. It can physically scratch the platter and do things. Most of the time now when a head hits the platter, what actually happens is the head itself gets damaged because it's a small piece that sits at the end. This is the way we basically write data on a platter at this point in time. We use this longitudinal recording mechanism, and this has been in existence for 50 years up until basically this year. This past year has been the first time that we've actually had drives that were introduced that were different than this method. So it hasn't really changed over time at all. The only thing that has really changed is the areal density of the drive. So as we've increased the amount of space that we can write data on, it starts to cause this problem where you get bits that are flipping. And that's called the superparamagnetic effect. And they've known that this was going to happen. They've